Problem group number 8 is just as fun as the first 7. I'm enjoying these. I love these reviews because you actually just to crank out derivatives, that's the fun part of all of this. Learning how to do it is the part that hurts. But now we're just applying the rules and getting good at it, coming up with elegant, ugly, beautiful, ugly answers. Now you know I hate writing sine squared of x because it doesn't make sense to write that way. It should be sine of x squared. First off, it reminds you this is the outside function. But also close the function, then do the exponent. Yeah, I don't know why they do that. I just don't know why they do that. This is the same thing. We'll do it this way. My way. Now, the derivative of natural log is 1 divided by its input. That's sine of x there. And then, of course, we're going to get chain rule. So we're going to get the derivative of sine. That's going to be cosine of x there, like that. Minus exponent, outside function, comes down. 2 times a half is 1, so we just get sine of x there. But then, of course, sine of x itself is an inside function there, so it's going to be times the derivative of sine, which is cosine of x. So I think the easiest way to write this would be just to say, hey, this is cotangent over here minus sine of x cosine of x. We could probably also write it as cosine of x, and then you could write it as, what's the 1 over sine? That's cosecant of x minus sine of x. These are the same thing. So either one, take your pick. Pick your poison. Okay, the next question actually looks somewhat difficult. So I'm looking forward to trying this out. I'm getting a delay in frame rate. I hope that doesn't come out on your side. Okay, what do we have? Well, before anything, let's just remember how to find the derivative of arctangent, because there's no way you remember that off the top of your head unless you're a rock star, which I am not. My memory is awful. That's why we have to be able to solve things. But I know that these two statements are the same. If I reverse them, now it's just a tangent function. We can find derivatives of tangent because we know that. So let's take the derivative with respect to x of this. We're going to get 1 equals secant squared of y. You know that I think this is a bad way to write it, but since this textbook's going to write it this way for your test, I'm just going to skip right past that philosophical point. And we also know that secant squared minus tangent squared equals 1. That's one of like the 3 identities you actually have to remember. So remember it. And that means if I solve for secant squared, I can rewrite this as 1 plus tangent squared of x, like that. And the one thing that I left out here is when I created secant squared from this, I forgot to write my dy dx like that. So this is going to need it on the outside, like this. Don't miss that. I was moving a little fast, and I almost made a mistake. So that's equal to 1. And that means our dy dx is going to equal 1 over 1 plus tangent squared of x, like that. Well, that's not very helpful yet, and I mean tangent of y, tangent squared of y. Wow, what an error. Don't make that mistake. Tangent squared of y. Oh my gosh. That was almost a big fat faux pas. I should edit it out, but I don't care. And the reason that we make this is because we know that x is equal to tangent of y. So I can rewrite this as 1 over 1 plus x squared. And that's the derivative of arctangent. So I'll just write that real quick over here to remember it, because I'll forget as soon as I erase it. And then we can erase all this stuff over here. Zip, 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 zip. I think it'd be faster to just do a fast select like this. And now we can solve the actual derivative. And no cheat sheet required. So y prime is going to be dominated by a product, 2 functions of x multiplied, so that's a product rule. We'll write it u prime v plus v prime u, and then we'll just write out what those are. Derivative of x is 1. V is arctangent of 4x, like that, plus v prime which is 1 over 1 plus x squared. That's the input squared, which is 4x squared, right? This is an algorithm, not an x. It says this is the input here. Your input was this. And chain rule, inside function yet, that's times a 4. That is the most common mistake on this problem, I'm willing to guess, next to this, unless you have your cheat sheet because you went to a state university and they don't make you derive it. And then times u, so we have an x on the outside for the end of the product rule there. So our answer is going to be arctangent of 4x plus 4x over 1 plus 16x squared. That's as simple as this derivative is going to get. Last question looks like it's going to be a doozer. Let's find out. Really fast, do you remember the derivative of secant or tangent? I will show you how to work it out very quickly. Let's say you have secant written like this. Well, if I want to take the derivative, now I can just do a quotient rule. So I'll just take the derivative of this really quick. Quotient rule says u prime v minus v prime mu over v squared. How do we do that? Do you remember? Anybody? Bueller? Well, what's u prime? That's 0. The numerator, the derivative of 1 is 0, so that's just out. Now we have negative v prime, which makes it a positive sine of x, times u, which is 1. So you just get sine of x on top. You don't even need the plus sign. Over v squared, which is cosine squared of x. Well, that's tangent. And then all that's left is a cosine on bottom, so that would be a secant. So secant tangent is the derivative of secant. I bet you remember that now that you've seen it. Now let's do it for tangent really fast, because I'm assuming we're taking a test and we don't get to look it up. Again, u prime v minus v prime u over v squared. Yeah? So let's just do it really fast. What's u prime? That's cosine times v cosine minus v prime, which is plus sine now, times u, sine. So that's 1 on top. Cosine squared plus sine squared. You follow that? So it'd be 1 over v squared. That's cosine squared. So that would be secant squared of x is the derivative of tangent. If you didn't remember it, now you know it. Okay, so let's erase those two and apply them to this problem. You got to make sure you have your little parts. You got to have your little Legos before you can build your tower. Okay, so we have the natural log of secant of 5x plus tangent of 5x. And they put an absolute value in here, which is for domain accuracy purposes. We're going to mostly ignore it because we're here to do the derivative stuff. So what's the derivative of this? Well, the overarching function is natural log. The derivative of natural log is 1 over the input. So we'll just write secant 5x for now, plus tangent 5x. And then it's times the derivative of the inside function, isn't it? So what would that be? What's the derivative of secant 5x? That is going to be secant tangent. Didn't we just find that? So it'd be secant 5x. Oh, Cooper, you're fine. Tangent 5x. And then times chain rule 5. Yeah. And now it's plus. What's the derivative of tangent? That's secant squared of 5x times chain rule 5. There's an inside of an inside here. So we can take the 5 out and a secant out, I'm thinking. It seems that way to me. It's in my bones that that would be the case. So I'm going to write it for now as like 5 secant of 5x times tangent 5x plus secant 5x. We'll think about whether we can factor this in a minute. Over secant 5x plus tangent 5x. If this is all in sine and cosine, it would be uglier, but it would be easier to see how to factor. So can we simplify this any further? I think we can work this out. Because we have, oh, check it out. This matches this, which means they cancel. There's the magic. There's the magic. So the derivative of this hideous thing up here just becomes 5 secant of 5x. Took a second to spot it. I hope you saw it faster than I did, but that's exactly why we factor things out. Because if you use a methodology, you don't need to look at each piece altogether. You can work on each one individually and then step back and look at the picture. Okay, well that was a quick problem set number 8. We'll do maybe number 9 and number 10, and then we're going to move on to a different form of calculus called integration.